All right, guys, let's now move on to limits. You have a couple of problems with limits on the exam, so I would say this is one of the most important parts probably. Now, I'll be solving part A in this video, but just before I get into this particular problem, I wanted to tell you two main things about limits. Firstly, whenever you're given a limit, the first thing you should do is always plug in x. Now, what do I mean by plug in x? So in the limit, you're given some value of x. X approaches 1, for example. First thing you should do is take that value, in this case 1, and plug it in and just calculate to check what the result is. In some rare cases, you might actually get a number, like 2/3 or 5 or whatever, and that's your final answer. You don't need to simplify anything. Now, to be completely honest, on the midterm, it's very unlikely that you have such an easy problem. Most of the time, you are required to do additional manipulation before you get to the right answer. But even if you don't get a number, you are required to do the first step, which is to always just plug in the value that x approaches and check the result. Now, when you're calculating that result, there are a couple of possible things that might happen, a couple of possible outcomes. The first one is you get a number, right? For example, 2/3, and that's your final answer. That's the easiest one, but as I said, you probably won't really see this on the exam. Now, second option is you get 0 over some number, for example, 5. If you get this, then you just calculate it. 0 divided by 5 is 0, so that's your final answer, right? Again, very unlikely, but you should know it because that's how the math works. Now, the third and fourth case are more likely. Third possible case is you get something, some number. It could be any number, by the way. I'm just picking a random one now, but it could be any number over 0. Okay? Now, this is going to result in some sort of infinity, and depending on the sign in the numerator, it could be minus or plus infinity. In this case, because I have minus 5 in the numerator, it's going to be minus infinity, but if I had gotten 5 over 0, then it will be plus infinity, okay? And the last option is that you get 0 over 0, which is the so-called indeterminate. Let me Google it. I don't remember how it was called. Indeterminate form. Not sure. Indeterminate. Okay, indeterminate form. Okay. And if you get this, it means you should go back to the original limit and you should try to somehow manipulate the expression in order to avoid getting 0 over 0. There is a way through rationalization or through any other techniques that you'll see in the following problems to avoid 0 over 0. But again, these are the different scenarios you might get. If you get like 0 over a number, then it's just 0 and that's your final answer. If you get a number over 0, then it's either plus or minus infinity. And if it's 0 over 0, that's the case when you need to go back and manipulate the original expression, okay? So these are the cases that are possible for all limits that we're going to be solving. Okay, that was actually the second thing that I wanted to mention. So these are like the prerequisite steps that I wanted to tell you. And now we can just start solving. This is probably going to bug us. So let me just move it to the end of the page like that. All right, so let's take a look at this first limit. So first step, just plug in the value for x in the expression and see what happens, right? So in this case, I would have square root of 10 minus x. So x is 1, 10 minus 1, minus 3, over square root of 5 minus x. X is 1, so 5 minus 1, minus 2. Then here I have square root of 9 minus 3 over, that's going to be square root of 4 minus 2. Square root of 9 is 3 minus 3 over square root of 4, which is 2 minus 2. And this gives us 0 over 0. And that's indeterminate form. Most of the time you will get that form, but not always. So that's why I wanted to just caution you. It's really important to firstly do this calculation and then move on to manipulating the expression. So if it's 0 over 0, as I said, you need to manipulate the original expression. And the way you do it in these types of problems is through rationalization. Now, firstly, what do I mean by these types of problems? When should you do rationalization? Rationalization is something you should do whenever, either in the numerator or in the denominator, you see something of this form. Radical plus or minus some number, whatever the number is, okay? It could be only in the numerator or only in the denominator or in both. In this case, as you can see, we see it in both the numerator and the denominator. We have a radical plus minus number in the numerator, and then a radical minus a number in the denominator, right? So we'll actually perform rationalization twice. But again, in some cases, you might only need to do it once for either the numerator or the denominator, okay? And of course, it could be swapped, like you could have a number plus or minus some radical. That's, again, rationalization, okay? That's how you can recognize it in actual tests. So now the next important question is, how do you actually do rationalization? So starting with the numerator, how can we rationalize this? We can do the following. So we multiply the whole fraction by the following thing. You take this expression, you write it almost the same way, but with the opposite sign in between the radical and the number. So in the original, it's a minus, right? Now I'm gonna write a plus, and I could put this in brackets, by the way. It's kind of more convenient, but you don't have to. And then in the denominator, you copy the exact same thing, okay? The exact same thing from the numerator. It's just gonna be square root of 10 minus x plus 3, okay? These always need to match, because you cannot randomly introduce, I don't know what it's called in English, factors, in this case a fraction that I'm multiplying by, unless it can cancel out to 1. So your numerator and your denominator need to be exactly the same, okay? So you take that expression, you copy it in both the numerator and the denominator, but with the opposite sign, okay? And this way we have it rationalized. Now, in this particular problem, because we have the same structure in the denominator, we'll also need to rationalize that, okay? This is probably like the most complicated case. I don't know what your exam will look like, but it will probably only have like one of the numerator and denominator to rationalize, maybe not both. But I can recall having to rationalize both on an exam. I don't remember which test it was, so you should just be prepared, right? Prepared for the worst. But it's not that big of a deal. You just need to do the same thing for the denominator. So again, we'll multiply by a fraction. And again, I'll copy the exact same thing both in my numerator and denominator of that fraction, but just with a different sign. So here the original sign is a minus, I'm gonna put a plus, okay? So it's gonna be square root of 5 minus x plus 2 over square root of 5 minus x plus 2, okay? All right, good stuff. So that's how you rationalize. And now we continue calculating. So that's our current expression that we're working with. A very important thing for tests in calculus is to keep copying the limit part until you reach the point where you actually plug in the value. So at the end of the problem, you see that at one point we'll actually plug in 1 instead of x. That's when you stop copying the limit part. But before that, you always need to copy it after the equal sign, okay? Otherwise, you might lose some points. I know it's really annoying. It really annoys me to have to write it so many times, but that's how it is, okay? All right, so now let me just erase some of my drawings, because otherwise it might be a little messy. So now I'm just going to copy everything that I have in the numerator. It must be multiplied, so I have square root of 10 minus x minus 3 times square root of 10 minus x plus 3 times square root of 5 minus x plus 2. That's my numerator. And then for the denominator, I'll have square root of 5 minus x minus 2 times square root of 10 minus x plus 3 times, by the way, I'm just copying from above, nothing fancy here. I just copied this part, and now I'm copying the lower part, the denominator, right? So I have square root of 5 minus x plus 2, okay? We keep going, we write the equal signs, the limit as well. And now, what can we see? Now, here's a really interesting pattern that's going to help us solve the problem. This is the same as the formula a minus b times a plus b, right? Because we have one thing minus another times that same first thing plus the second thing, right? This is, again, not even calculus material. This is just like a formula that you need to be able to recognize. So in this case, okay, let me just write a full formula. Come on. The full formula is, this is going to equal a squared minus b squared. In this case, our a is that portion, right? The square root of 10 minus x, and 3 is going to be our b, all right? Therefore, if I were to simplify this whole thing, I would have square root of 10 minus x, that's my a, and then I need to square it, right? Minus my b, which is 3 squared. Okay, that's my first expression. And then I still need to, so that's the whole thing. And now I still need to copy this part. So I'm going to multiply by square root of 5 minus x plus 2. Okay, in the denominator, I have a similar thing. So look at how I have square root of 5 minus x and minus 2 times square root of 5 minus x plus 2. This is the same formula. This is again the sum of differences. The difference of squares, not the sum of differences, oh my god. The difference of squares, okay? That thing. So I'm not going to explain it in detail because I already did for the previous one. But this is basically just going to be square root of 5 minus x squared minus 2 squared. Okay? And then that intermediate expression I just copy. So 10 minus x plus 3. All right. I keep copying the limit and I move on. Now here, I'll just expand, right? So if I have a radical raised to the second power, the radical and the power just cancel out, and I'm left with whatever is inside of the radical. So that's going to be 10 minus x. And then I have this minus 9, right? And I don't even need these square brackets anymore. I can keep it like that. And then I just copy the rest of it. So it's going to be square root of 5 minus x plus 2. In the denominator, we have a similar thing. So again, the square root and the second power will cancel out. So I'm left with 5 minus x minus 4, because 2 squared is 4, times square root of 10 minus x plus 3. Fantastic. Okay, let's move on. Limit as x approaches 1 of. Now we have 10 minus 9, which is 1, minus x. The rest of the expression I just copy, because I cannot simplify it any further, right? 5 minus x plus 2 over. And now, interestingly, here 5 minus 4 is also 1, so we'll also get 1 minus x, which is really cool because now we can cancel things out, right? This I just copy. Square root of 10 minus x plus 3. Okay, so you should be very careful when canceling things out. You can only cancel things out when you have multiplication, like in this case. If you had a plus here or a minus, you would not be able to cancel out things, okay? So please be careful with that. But in this case, we have the perfect conditions to cancel things out. That's the greatest pleasure in math, when you start canceling things out. And now we're left with limit as x approaches 1 of square root of 5 minus x plus 2 over square root of 10 minus x plus 3. And now you'd probably be like, isn't this similar to the initial expression? Like, did we really do like 10 lines of work just for us to reach an almost same expression? But trust me, it was worth it, because now the signs are different. And how does it help us? Well, now if we just plug in x equals 1 everywhere when we have x, right? So if we just plug it in, we won't get 0 over 0 anymore, because 0 over 0 is our problem, right? But in this case, we would have square root of 5 minus 1 plus 2 over square root of 10 minus 1 plus 3, which is square root of 4 plus 2 over square root of 9 plus 3, which is 2 plus 2 over 3 plus 3, which is 4 over 6, which can be further reduced to 2 over 3. But that's our solution. That's our final answer, right? So sometimes even achieving the nearly same expression as the first one, but with opposite signs, does help us, right? Because now we don't reach 0 over 0 anymore. And that's our final answer for this problem. By the way, this is not always going to be symmetrical. Like whenever you do this, you're not always going to get almost the same thing with pluses and the swap places of the 2 and the 3, so don't just rely on that. It's just that in this case, it's very similar, okay? But yeah, that's the strategy. I know it might look very confusing at first, but actually, the only thing you need to think of is to rationalize. You need to know how to rationalize, right? How to do this. And from there, it's purely calculational stuff. It's basically high school formulas. In case you don't remember them, please don't feel bad. I'm not trying to make you feel dumb. Not remembering formulas, by the way, is not a sign that you're dumb anyway. I don't remember formulas. I mean, I memorize formulas for tests and then forget about them. So it's not a problem at all. You just need to, memorize them for the test. For example, this formula is really important, as I've said in previous videos. You need to remember that formula. And then you need to recognize that whenever you have the same, almost the same expression, but with a different sign, then that's the difference of squares formula. Okay? And once you know it, the rest of it is decently easy. Okay, enough for this one, I guess. Let's move on to the next one in the next video.